Okay, in this part of the video we're going to discuss the crankshaft. And one of the things in a stock engine, stock visible V8, this is the kind of crankshaft that you'll find, of course. And when you get the visible V8, you'll find the parts here. You'll have to you just assemble these parts. They all just stick together. They all just basically you just put these parts together. You just follow A through H, and you just put them together like that. Well, that's fine for stock visible V8, and then of course you have put your rods on, and that's fine. Here's your rods right here. But for high-speed operation, that's not going to work too good. So, one thing I'd like to point out, right here, what you see here is my collection of broken crankshaft parts. And this has all been had a problem during testing. So these things at $50 a piece, it starts to add up after a while. So the goal is to not have that problem. So one of the problems here, meltdown. I don't know if you can see it in the video, but this has all been, this crank pin's melted down. This crank pin is melted out of shape. There, it's off at a melted off at an angle here. And these high speeds, it gets hot and melts down. So it's been a real challenge to overcome that. And I've managed to more or less overcome that. And here is crankshaft number 6 of the latest round of crankshafts. Actually, there's more than 6 crankshafts, but this is out of the latest engines. And one thing, it kind of looks simple, but this crankshaft takes about 4 days to put together. It's kind of a complicated process, and it's very difficult to get the crankshaft to be, you have to make it in line and true as you can. So it's about a 30-step process to make one of these, and it takes a while to make one. So I try not to burn up too many. One of the things, so I'm going to point out some of the features of this crankshaft. One of them, first things, there's a stud here in front, and that stud is there's a spacer. This is an oil slinger right here, and you got a gear. Where's the gear? Got a gear. This is the cam gear right here. This gear is made out of epoxy. It's cast out of epoxy from a 1960 gear, and it's a little bit wider. The gear is the same size, but I figured out a way to make them wider. Then you got a spacer here and an oil slinger right here, and this fits on like that. And then there's and of course your pulley here, the pulley, crankshaft pulley, fits on like that, and then there's a nut that fits on right here, like that. And that's what holds everything together here. And of course you got this sits on here. Timing gear cover. That fits on there, and then the nut fits on there. Like that. So that's what holds on the pulley. The stock pulley after you get over about 1500, 2000, sometimes they'll just fly right off. There's nothing to hold them on. But as you can see in the video, this combination here, through experimentation, has been able to hold up to over 7,000 RPM. So that's what you have here. And now let's go down, and at the end of this, at the other end, of course, here's your torque converter. This torque converter is set up so that there's a nut welded inside here, and the torque converter has a screw inside here, a nylon screw, and put that on like that, and you screw this on. That. Yeah. Now, this torque converter is solid on to the crankshaft, and you can take it off. And you, when you're assembling it, you can take it off and put it on. Assemble and disassemble it, which makes it real nice. All the crankshafts used in my videos use the later model. Crankshaft. The earlier model crankshafts have a different torque converter, and they have a different end on the crankshaft. So I use this in all the later. I use the later ones in all the videos that I make, because I can get the parts, and the other parts are a lot more expensive. So now let's talk about the crankshaft itself here. This is kind of the heart of the whole thing. This is where it all gets, this is where it all comes together. And one of the things is, in the block, we talked about the block here, the holes here that feed the bearings for the oil. They line up with this. They line up with the holes here in the crankshaft, right here. In the journals, the main journals here, and here, and here. So you got three of them here, and then of course the ends, they're just fed. They just feed the bearings, the holes here for the oil. They just feed the bearings on the end. But in the three in the center, the center three bearings, the oil goes in this hole here. Oops. Goes in this hole right here. You can see it. Goes in that hole, and then it goes from there. There's a passage that comes out here, right there in the middle, right there. And this is a calibrated hole. It took a long time to figure out the size of the hole to calibrate this to. It's calibrated so that the oil flow, you get the right amount of oil flow. And one of the things is it sets in the middle. Early on, I tried drilling holes on both sides for each rod, and the problem is that the oil went to one side or the other, and it caused to burn up the crankshaft. So this has proven to be a lot better to have just one hole, and it just distributes the oil, the lubrication back and forth to each rod. And so this is all pressure. This is all pressure fed, and it goes same way here. It goes here. This one here feeds this crank pin, and feeds that crank pin. And this one here feeds this crank pin, and this hole here feeds that crank pin. So the center actually feeds both crank pins. So now we have the block here, And we have the crankshaft here, and so the crankshaft just fits in the block like that, drops in, and of course your bearing caps. The bearing caps go on like that, and this is all set up. This is why it takes so long to. This is why it takes so long to make the crankshaft, because you have to make sure that the holes line up. The holes in the crankshaft line up with the holes in the block. So it's really tedious to get all the segments. Tedious to get all the segments to fit together so that everything lines up. Plus, you have to make sure the end play is correct. You have to have the right amount of end play, and the thrust surfaces are on the end here. So this has to be right, and it's this is one of the reasons it takes so long to put it together, and the and everything has to turn true, of course, as true as possible anyway, I should say. But and in this case it does. So, and also the caps here, the bearing caps, there are Teflon lined too, but in the center anyway, but not on the ends. And one of the reasons is because you want to maintain a good oil seal here, so that you get a good oil flow here. And I got a little chamfer on it. You can't see it in the video probably, but I got a little chamfer on here. It seems to help quite a bit. It's real critical that the oil flow is maintained to these connecting rod bearings journals here. It's very critical to operation. So, and another thing too, these these journal sizes are different. These are smaller and these are larger. So that's, the ones on the end are larger. So that's another reason that there's not any Teflon on the ends, but it doesn't seem to make much difference really on the ends. But here it seems to help keep the oil pressure up, and that's important to keep the oil pressure up here. So let's look at this, and I've had some people ask me on the email, say, well, this all looks great. Well, how do you get the how do you get the connecting rods on here? Well, this is how. The connecting rods, when they're stocked from the out of the box, they look like this. And of course, if you have this isn't going to work. Just like in a real car engine, it wouldn't work either, because this is solid. So there's no way to do that. So we have to do this. What happens is this is split. The rods are split. The stock rods are split, and you have Teflon inserts in here inside, and you have two screws, and these are nylon screws right here. These are 256 nylon screws, and you have to line these up. You have to make sure that you get them back together right. I got them marked here, and you just put that on there like that, like that. And then you just tighten them down. Oops, gotta get it on straight. Helps to get it on straight. We'll go through this in the assembly process. I'll show you how all this goes together. But anyway, it goes on. Anyway, this as you can see, this goes on here like this. like that, and then it just screws down tight, and just like that. And you just tighten the screws down, and when it's tightened down, it's just like that. And all the rods are labeled 1 through 8, and you have to put them together in exactly the same order. You can't mix up the caps. If you do, it's not going to work. You'll have a real problem. But this Teflon has proven to be very very helpful in maintaining keeping the crankshaft from overheating. And that's the biggest problem with the crankshaft. And that's one of the reasons the lubrication is more for cooling than lubrication, really. You have to keep all these crank pins cooled down, so you don't have this problem right here occur. So anyway, the Teflon inserts help quite a bit with that. Okay, let's move on to the piston. This is a stock piston, a stock rod. I've had no problem with these rods at all. These are original rods. I've had these same, well, I did have one problem. I had a split right here. I had a split. I had to change one of the rods out. Split right here. But I've had the seven rods are the same rods, and two of the rods are from 1960. So these rods have gone over 7,000 RPM. So I haven't had any problem at all, any rod failure at all. And the pins are held in. There's a screw right here, and the pins are held in with a screw. So with a nylon screw, so you can take them apart, but I've never really had a problem, so I've never had to take them apart. These are the original, these are stock pistons, and these are the original pistons that I had from before. I tried some other pistons. I tried many different piston combinations, trying to control the oil and the compression, and I finally wound up with this combination here. This is the top of this piston is Teflon. It's a bondable Teflon, the top of the piston, and since these pistons are numbered, this one says number 5, they're set up to match the bore. So this Teflon acts sort of like a ring. It's not really a ring, but it acts kind of like a ring, and it's matched to bore cylinder number 5. So it gives a pretty good seal, and I'll go into detail on that during the assembly. But one of the things I'd like to point out is in a visible V8, using this combination right here, you just really can't seal the engine. You can't seal the pistons very well. It puts an extreme load on the crankshaft if you have very much compression. The loading on the crankshaft, the twisting of the crankshaft is to the point where it'll just twist right in two pieces or more sometimes. So that's critical. And one of the main things here is oil control. You want to keep the oil. You want to keep the oil in the crankcase and keep it out of the upper cylinder area. And one of the things here, along with the Teflon top, is I have holes in here, and I drilled these holes in here, and this really does help quite a bit with oil control. It almost, not quite, but it almost eliminates my oil pumping problem, blow-by problem. So it's proven to work very well. And I didn't come up with this idea. Somebody else came up with this idea, and I copied their idea, and it works great. So that's the that's how this works here, just like that. Just like that. And it just screws in. And these are nylon screws. And here's one of the reasons to use nylon screws is you want to keep the weight down. The centrifugal force, you want to try to keep it in balance, and as close as I can tell, this combination with the nylon screws, which are very light, I can't tell any difference. So that's another thing I'd like to point out too. I can't see any difference in balance, but one of the things I'd like to point out is that I've never had to balance any of these crankshafts, or I've never had to balance any of the rods and the pistons. So I don't know how exactly, but it seems to come out in pretty good balance overall. There are some speeds that it's not quite in balance, but overall it's worked pretty good. So that's how that works. Let's the next part of the video we're going to have, and I'm going to do that later, but the next part of the video we're going to have is we're going to assemble the whole thing, and then we're going to run it up and see what we did, see how we did on the assembly. And I hope this kind of gives you an idea of what I've done. This has taken me, well, I worked on this a year before I made the first video, and so I've had some meltdowns, and I've had a few problems here and there, that's for sure. One of the things is, here's block. I don't have block number one. Block number one suffered a catastrophic failure, I guess you could say. But here's block number, this is block number 2 here. And this block here was in the first, I think, first 5 videos. This block was used here, up to 5,000 RPM. And one time at 7,000 RPM, and it had a little problem. So I thought, well, I'll make a new block, and this is block number 3. This is the block you see in the current videos right now. This is an improved version of this one, and of course this is an improved version of the first one that I had. And you learn something new with every meltdown or blow up. You learn something new, and I've been learning a lot here. So anyway, the next videos after the following videos are going to be the assembly, and then we'll have a run up, and so that's it.